service manager, is giving Ken the facts of life on troubleshooting the refrigeration part of an air conditioning system. It's sure to be an interesting session, so let's get closer to the action.
Of course, you might find the trouble in other parts of the system, such as compressor belts slipping, air doors not operating properly, or a water flow valve that doesn't shut off completely. But when it comes to the refrigeration part, this gauge set will tell you what's happening or not happening in the system. Right, Tech?
Right you are, Fred. But you've got to know how the refrigeration system works so you can understand what the gauge readings mean. Why don't you tell us about that first?
Okay, Tech. Keeping it basic, we can say that the refrigeration system cools the car by picking up heat inside the car at the evaporator and passing it off to outside air at the condenser. Now, to make this heat transfer process work, we use a special refrigerant which changes from vapor to liquid under high pressure and then under low pressure changes back from liquid to vapor. I'll explain why the refrigerant changes after we cover the operation of the system. The refrigerant is pumped around the system by the compressor. The compressor also increases pressure in part of the system, so the refrigerant will change from vapor to liquid as it gets rid of heat in the condenser. As it leaves the condenser, liquid refrigerant passes through the receiver dryer to remove any moisture and then flows to the expansion valve. To simplify our explanation, the system from the compressor outlet to the expansion valve inlet can be called the high pressure section. From the inlet, the expansion valve meters liquid refrigerant into the low pressure section, which begins at the evaporator inlet. Here, because the pressure is lower, the liquid expands, vaporizes, and absorbs heat from air passing through the evaporator fins. Then, as it leaves the evaporator, the low-pressure vapor passes through the suction line back to the compressor, where the change from vapor to liquid begins over again. Any questions up to here, Ken?
I'm with you so far, but I'd like to know why the refrigerant has to change from vapor to liquid and back again.
You've put your finger on two key parts of the refrigeration process, Ken. Here's what happens. We get cooling action because evaporating liquid absorbs heat and cools the surrounding area as it changes from liquid to vapor. However, the process stops when all the liquid evaporates. So to keep evaporation cooling going in a closed refrigeration system, a continuous supply of liquid refrigerant is provided by recycling the vapor which comes out of the evaporator. As you know, the vapor changes to liquid after it passes through the compressor and condenser.
Okay, that makes sense. Now tell me what the expansion valve does.
The valve reduces system pressure and controls flow into the evaporator. It meters in the amount of liquid that can vaporize fully and absorb as much heat as possible before the vapor leaves the evaporator. Now, if the expansion valve allows too much liquid into the evaporator, it'll flood. This means there's less room for vaporization and therefore less vapor to absorb heat, a point to remember when you're troubleshooting. At the other extreme, if the expansion valve starves the evaporator, there's not enough liquid coming in and vaporization is cut down, again reducing heat absorption and cooling.
Before you go any farther, you'd better tell us how the expansion valve is controlled.
Coming right up, Tech. The expansion valve is controlled by refrigerant temperature and pressure at the evaporator outlet. The temperature is sensed by a thermal bulb in the suction line. Pressure reaches the valve through the equalizer tube. When the right amount of refrigerant is metered into the evaporator, the suction line temperature and pressure control forces balance each other. The balance keeps some refrigerant fluid distributed throughout the evaporator without allowing any fluid to leave the evaporator outlet. Now, if the evaporator starts flooding, evaporation is reduced, so the suction line pressure remains relatively high with a low temperature. These changes alter the balance in the expansion valve. It starts closing and refrigerant flow into the evaporator is reduced. Where the evaporator begins starving, refrigerant vapor expands to the point where suction line pressure is relatively low, but with a high temperature. Here, the expansion valve starts opening to meter in more liquid, and the balance is again restored. And that covers all the parts you need to make a basic refrigeration system work.
Well, there's more than that to a car refrigeration system, isn't there?
The basic system Fred described will cool all right, but it'll operate only at full capacity. We need another control besides the expansion valve so the evaporator won't get too cold and clog its fins with frost.
Our systems use either of two methods for limiting the low temperature. In one, the cooling cycle is interrupted by disengaging the compressor clutch. In the other, the cooling cycle is slowed down by restricting refrigerant flow at the compressor inlet. Here's how they work. Clutch cycling is used in air conditioners which are factory installed on compact models and in dealer installed Mopar units. Here, an electric thermal switch senses temperature changes in the evaporator and opens and closes to cycle the system. Before the evaporator gets cold enough to freeze, the thermal switch shuts off the current to the compressor clutch. When the evaporator warms above the critical point, the switch closes the clutch and the cooling cycle begins again. In other models, the refrigeration cycle is controlled by an evaporator pressure regulator valve built into the compressor. In this system, suction pressure at the compressor inlet operates the EPR valve to control refrigerant flow and prevent evaporator freezing. To understand how this works, you must know that refrigerant pressure and temperature are directly related. In other words, the pressure in a sealed container of refrigerant rises or lowers a specific amount with each degree the temperature goes up or down. Since refrigerant acts the same way in the sealed refrigeration system, a warm evaporator will raise the suction line pressure high enough to open the EPR valve. The wide open valve allows full refrigerant flow in the system for maximum cooling capacity. Then, as the evaporator cools, refrigerant pressure in the suction line drops and the EPR valve begins to close. As the valve operates, it modulates refrigerant flow just the right amount to slow down the cooling process so the evaporator fins will not frost up.
The EPR valve keeps pressure in the low pressure section from dropping below 22 pounds. This is the lowest back pressure which will keep the evaporator from freezing. And that wraps up operation of the refrigeration system. Ready to get at troubleshooting, Ken?
Yep. Let's connect the gauge set and take some readings.
Not so fast. We'd better talk about troubleshooting strategy first so you can plan your tests. You see, refrigeration system diagnosis is concerned with two general trouble conditions. The first condition is insufficient cooling. This can be caused by an incorrect refrigerant charge level, air in the system, or defective system components. The gauge tests will show up the cause of trouble. The second condition is no cooling at all because the system is empty. This condition usually results from a leak, so you'll have to find the leak first and correct it before any other tests can be made.
Compressor crankcase oil can be lost from a leaky system, so be sure to check the oil level before you charge the system after fixing a leak. And don't forget what Fred said earlier about belts, air doors, and the water valve. Check them all.
Thank you, Tech. Now, no matter if the refrigeration system is charged or empty, you'll need the gauge set for either testing or recharging. So first, we'll connect the gauges and see whether the system is charged or empty.
Be careful how you handle those gauges, Ken. If they're dropped or banged around, the shock can throw their accuracy off. If a gauge is off only a few pounds, it can mislead you into replacing good parts or the wrong part.
Gauge accuracy should be checked at least once a month so you can rely on the pressure indications. You can test the gauges yourself. All you need is a nearly full can of refrigerant and an accurate thermometer. Tape the thermometer to the can so its thermal sensing element is below the liquid level. Then connect the refrigerant can to the hose of the gauge to be tested. Put the whole rig somewhere overnight where the temperature is stable. In the morning, compare the thermometer and gauge readings against the temperature pressure chart in your service manual to check the accuracy of the gauge.
Just a second, Fred. We'd better have someone turn the record before morning gets here, so we can go on with this session. When the gauges are not connected, it's a good practice to put plugs in the hose couplings to keep dirt and moisture out. Also, make a habit of keeping both gauge manifold valves closed to prevent accidental refrigerant discharge when the gauge set is connected. And to play it safe, remember that escaping refrigerant can freeze on contact. So wear goggles and also protect your hands when you open the refrigeration system for tests or servicing. Refrigerant does not damage painted surfaces, but will tarnish bright metal and chrome. So be careful.
Good points, Tech. Now, before you connect the hoses, make sure they're in good condition. Also, check the coupling seal inserts and the valve depressors. If an insert is missing, refrigerant will leak out and the gauge reading will be inaccurate. The valve stem depressors in the couplings release refrigerant when the couplings are screwed on. However, you can cut down refrigerant loss if you press the coupling seal insert tightly against the service port while tightening the coupling. The suction pressure gauge at the left of the gauge manifold and the discharge pressure gauge at the center are used in testing both the clutch cycling and EPR valve-type systems. The compressor inlet pressure gauge at the right side is not interconnected with the other two. It's used only with the EPR valve system.
Okay, but how can I remember which hose goes where?
Well, in either type system, the high-pressure center gauge always connects to the discharge service port at the front of the compressor, so you shouldn't have trouble there. Incidentally, the lower valve under the center gauge is used to slow down pointer movement. Now, for the clutch cycling system, you're only concerned with connecting the suction pressure gauge on the left side of the set. And there's only one other service port available, and that's on the cylinder head of the compressor. With the EPR valve system, however, there are two service ports and two low-pressure gauges to connect. But here, the suction pressure gauge on the left connects to the service port at the rear of the compressor. Then the inlet pressure gauge on the right connects to the service port on the cylinder head.
What's the outlet below the gauges for?
The manifold outlet's used for charging, discharging, or evacuating the system, and is controlled by the two manifold valves. The gauges have direct passages to their connecting hoses, so they're not controlled by the valves.
When everything is connected, momentarily loosen each manifold coupling to purge air out of the hoses. Make sure the needle valve under the center gauge is open. Now, using the EPR type system as an example, system pressures will gradually equalize at rest. So, all three gauges should indicate the same pressure before the engine is started for system tests. The overall pressure will vary according to the temperature of the system, but will be uniform at each test gauge. Obviously, no pressure at all means the system is empty. If the gauge check shows refrigerant pressure, warm up the system to normalize all the parts so you can make accurate tests. Run the engine at 1300 RPM for 15 minutes with the car doors and windows open. We'll do all of our checking at this speed setting until we get to the EPR and expansion valve tests. After the engine is started, move the temperature control to off. Push in the max cool or max AC button and put the blower control on the high speed setting. While the system is warming up, you can check the air doors and the water valve as described in your service manual.
When the system is warmed up, you can make a preliminary pressure check before making the tests given in the service manual. This quick check helps you narrow down possible trouble sources, but does not replace the service manual tests. Tell them what to look for, Fred.
Okay, Tech. Now, if abnormally high discharge pressure shows on the center gauge between 240 and 300 pounds, it can mean an overheated condenser, restricted refrigerant flow, or a flooded evaporator. The condenser will run hotter than normal and cause high pressure in the system if airflow through the unit is restricted by dirty or bent condenser fins. Of course, hot weather will run up condenser temperature too, especially with slow traffic or prolonged idling. Restricted refrigerant flow can be caused by a kinked line or by air collected in the condenser. Either condition will build up back pressure at the discharge gauge, but air in the system also causes foam in the sight glass on the receiver dryer. Evaporator flooding usually results from an open expansion valve. However, too much refrigerant in the system can flood the evaporator even when the valve is okay. Both conditions cause high discharge pressure accompanied by high suction pressure.
Great. But how do I tell which one's the cause?
You can put the expansion valve thermal bulb in ice water to test the valve. If the suction pressure drops, the valve's okay, and you know there's too much refrigerant in the system. Fred will tell you what to do about that further on. Right, Fred?
Right, Tech. Now, at the other extreme, if discharge pressure is lower than normal, it's usually a sign that the evaporator's not getting enough refrigerant. Here we may find a kink in a line, low refrigerant charge level, or a starved evaporator. The refrigerant charge level can be lower than the amount specified for the system if some refrigerant was released accidentally or an incomplete charge was previously added. Where the level is lower than normal, all the gauges indicate low pressure, but the side gauges do not go down to 0 or below. To check for low refrigerant charge level, boost the pressure on the center gauge by blocking airflow through the condenser with a fender cover or cardboard. If foam shows in the sight glass with discharge pressure between 225 and 250, the level is low.
You've mentioned high and low refrigerant charge levels. How do you get the correct level?
Well, you can use the same general procedure for both. In either case, we'll end up by adding some refrigerant. So first, arrange a refrigerant source for system charging. Now, to correct for low charge level, you follow manual instructions and add refrigerant until no foam appears in the sight glass. But where the charge level is high, you release refrigerant in the approved manner until the foam appears. Then, in both cases, you add exactly 1/2 pound of refrigerant to make up the correct charge. Now, where a starved evaporator causes low discharge pressure on the center gauge, suction pressure on the left side gauge will also be low. Here, unlike the low refrigerant condition, the right side gauge will drop to 0 or lower. Usually, a starved evaporator means a closed expansion valve.
To find out if the expansion valve will open, warm the thermal bulb in your hand. If gauge pressures remain low, you'll have to replace the valve. Now, Fred, what can we expect to find if suction pressure on the left side gauge is higher or lower than normal?
Well, high suction pressure can be caused by too much refrigerant in the system or an open expansion valve. However, where both side gauges read high and remain high when you speed up the engine, the cause can be low compressor output capacity. Now, in the opposite direction, low suction pressure can be caused by a starved evaporator or an EPR valve not modulating properly. You can spot a starved evaporator because it puts out warm air. However, an open EPR valve cannot slow down the cooling cycle, so air from the evaporator will be cold even below freezing.
If suction pressure on the left side gauge is lower than the normal 22-pound minimum, and inlet pressure on the right side gauge drops to 0 or below, you'll probably find a closed expansion valve.
Where the EPR valve stays open, both side gauges indicate the same lower than normal pressure, but neither will drop to 0 or below as with a closed expansion valve. Just remember that the suction pressure must not drop below 22 pounds.
By now, you should have a good idea of what can make the gauge indications act up. So if the gauge readings are still off after you've made sure there's no air in the system and the refrigerant charge level's okay, follow the service manual directions and check the expansion valve, the EPR valve, and the compressor.
Okay, but what if the pressures are normal, after adding refrigerant, for instance?
Where the pressures read normal, the system's probably working at full capacity. But to be sure, you'll have to run a system performance test, especially if the weather's hot and humid. You see, where the humidity's high outside, the air in the car will not get as cool as in low humidity weather. However, it usually is reasonably comfortable in the car because the air conditioner lowers the humidity. Explain this to the customer and use the performance test to demonstrate that the system is working at full capacity. Now, a few final precautions. When you disconnect the discharge pressure hose, it'll release the high-pressure refrigerant in the hose, so protect your hands against freezing. Check the hose couplings to see that the plastic inserts are in place. Replace the caps and plugs, close the valves, and the job is finished.
Well, you sure gave me plenty to think about. Now I can see why the test gauge pressure indications are so important for troubleshooting.
As you get more refrigeration system servicing experience, you'll pick up other clues that'll help you turn these jobs out in a hurry. And to make troubleshooting easier, you'll find more about gauge tests in the reference book for this session. Read it and put it in a safe place for future reference. Always make sure you're following the correct service procedures by checking your service manuals. Well, happy air conditioning, fellas. See you next month.